one last example that we're going to take a look at of being able to minimize distance. So we have this line y equals 6x, and we have a point 74, 0. And we want to find the least distance between the point P on the line and then 74, comma 0, just to give you an idea of what we're looking at. So y equals 6x is a really steep line passing through the origin, maybe something like this. And let's just say 74, 0 is way out here. All right, and not the scale. And we need some point that's going to be somewhere on our curve. All right, so maybe like right out here. I don't know. All right, but let's just estimate that. And this is our distance d. All right, now we know the point on the line is going to be x comma 6x because y is equal to 6x. All right, so that's really our secondary equation. And what is that distance? It's certainly not a small distance because 74 is a big value. All right, so let's go ahead and set it up. We recall that the distance formula d is going to be equal, I'll use capital D because I think that's what my math lab uses, so I'll use that, is going to be equal to the square root of x2 minus x1 square plus y2 minus y1 square. And let's just define x1, y1 to be the stationary point 74, comma 0, and the point that's variable, the one that we just don't know at this point, let's call that x2, y2. And we're just going to substitute immediately into the distance formula. So we are going to get the square root of x minus 74 squared, and then plus 6x quantity squared. Now, technically, that's 6x minus 0. Let me throw that in there, just so that way everybody's consistent with what's going on here. Okay. Now, we can go ahead and we can square this out. All right, so if we square this out, we're going to get, remember, this is x minus 74 times x minus 74. All right, so that's our x minus 74 square. I just did that off to the side. So we're going to get x squared minus 74x minus another 74x, and then plus 74 squared, which is going to be 5476. Not that it matters, because it's going to go away anyway. And 6x squared is going to be our 36x squared. Right? And then simplifying that just one last time, that's going to give us 37x squared. So we have like terms. Negative and negative is going to be a negative 70, 74 and 74 is a minus 148x. And then we have that 5476, which is very inconsequential to us. You might remember in the last video, if we square the distance, we're optimizing the distance itself. So let's just square the distance and get 37x squared minus 148x plus 5476. And now we can just go ahead and we can take the derivative. So I'm going to say the derivative of d squared with respect to x is going to be 74x minus 148. And we're going to set that derivative to 0. And now we're almost done with this because we just add 148 and divide by 74. So x is equal to 148 over 74. And then what we can do, we can just go ahead and divide that out. So we can go ahead in our calculator. So 148 over 74, and that's 2. So that's really nice. That usually doesn't happen. By the way, you might remember that you can use the trick that if you end up with a fraction that's not in lowest terms, so let's just say for some reason we had 20 over 32, and we just wanted to, what you could do is you could hit math and then enter. You could put that into a fraction in lowest terms, which might be helpful when you're doing the MyMathLab stuff. Right? So x is equal to 2. Remember that y is equal to 6x. And so the point is going to be 12. All right, so the point that we're looking at is going to be 2, 12. All right, so that's nice. But it also asks us to find the distance. All right, so what is the least distance? And that's when we're going to use this formula. right? So all we're going to do is we're just going to substitute 2 back in. And like I said, it's going to be a pretty large distance. So the distance d, which is equal to the square root of 37x squared minus 148x, I believe, plus we have 5476. So d, I'm running out of room, but I'll be just about done. 37 times 2 squared minus 148 times 2, and then plus 5476. All right, so we're going to calculator that. Remember, we're trying to find the original distance, not the square of the distance. So that's 37 times 2 squared minus 148 times 2, and then plus, not minus, 54, whatever it was, 5476. All right. And we get 72.993. All right, so we'll just approximate that. Sure you don't want to see my email or my background. So once again, I lost what it was, 72.993. All right, so make sure you're rounding appropriately. All right, MyMathLab might ask you to round to 2 decimal places. All right, so hopefully that helps you to be able to optimize these sorts of functions, finding the shortest distance, etc.